Hi everyone. Today we are going to discuss about large language model, that how we can create the text and image models. So generative AI is a type of artificial intelligence that can create a new content based on the information it has learned from large data sets. For example, when we give a prompt such as explain artificial intelligence in simple words, text generation model can generate a complete answer. Similarly, if we provide a prompt like create an image of a futuristic city, an image generation model can create a new image based on that description. So in this presentation, I will explain the major text generation models, image generation models, their architectures, advantages, and comparisons, and some important practices for using these models in real world applications. So text generation models. So let us look at text generation models. Text generation models are AI models that can understand and generate human-like text. There are commonly based on the transformer architecture. So these models are trained using very large amount of text data. During training, the model learns patterns between words, sentences, concepts, and different types of information. Once trained, the model can generate responses for tasks such as answering questions, writing content, summarizing documents, translating languages, generating code, and solving reasoning problems. So, in this section, we will mainly look at three important model families: GPT, Google Gemini, and Meta Llama. The first model we are looking at is GPT-4 from OpenAI. So GPT models are based on the transformer architecture. The slide mentions dense and mixture of experts architectures, that is MOE. The important idea is that these models use a very large number of parameters. Parameters are the internal values that the model learns during training. So these parameters help the model understand relationships between different pieces of information. So GPT models are designed for tasks such as reasoning, coding, mathematics, and natural language understandings. So another important part is the ecosystem around the model. So GPT technology can be used through applications such as ChatGPT and developer APIs. It also supports capabilities such as function calling, structured JSON output, vision understanding, and reasoning. Function calling is especially useful for AI agents because the model can interact with external rules or application. Structured JSON output is useful when developers want the AI response in a specific machine readable format. So overall, GPT-4 is not just a text generation model, it can also act as a foundation for building intelligent application and AI agents. Google Gemini native multimodality. So, so next we have Google Gemini. One of the major features highlighted here is native multimodality. Multimodality means that the model can work with different types of information such as text, code, images, audio, and video. According to the slide, Gemini was designed from the beginning to work across these different data types instead of simply adding separate vision or audio systems to a text model. For example, we could Provide an image along with the question and ask the model to explain what is happening in the image. We can also use multimodals to analyze videos, documents, or code together with natural language instructions. Another important capability mentioned on this slide is long context handling. So, context refers to the amount of information the model can consider while generating the answer. A large context window is useful when working with very large documents, research papers, large code bases, or long videos. Therefore, Gemini is particularly useful for applications where different types of data need to be understood together. MetaLambda and open source LLMs. The third text model family is MetaLambda. One major difference between MetaLambda and many proprietary model is its open weights approach. Open weights gives researchers and developers greater control over how the model is used, customized, and deployed. So, this is useful for organizations that want to build AI systems for specific domains. The slide also shows different parameter sizes such as 8 billion, 70 billion, and 405 billion parameters. So, different model sizes provide different trade offs between performance and computation requirements. A smaller model can potentially be easier to run on local hardware, while larger models generally require more computational resources. Another important advantage mentioned here is data privacy and control. So now we are moving to the second major part of the presentation is image generation model. Image generation models are generative AI system that can create images from text descriptions or other forms of input. For example, if we give you a prompt such as a robot working in a modern laboratory, the model can generate an image based on the description. So, these models are useful in areas such as advertising, graphic design, entertainment, education, product design, and creative content generation. The two important examples covered in this presentation are DALL-E and Stable Diffusion. The first image generation model is DALL-E 3. One of its important features is prompt alignment. A prompt is the instruction that we provide to the AI model. For example, instead of simply saying a car, we can provide a detailed description such as red sports car parked beside a modern glass building during sunset. So, DAL 3 can interpret the meaning and details of the prompt and generate an image and attempts to match the description. So this slide also highlights its integration with ChatGPT. So this means that a simple user idea can be transformed into a more detailed prompt before image generation. So this reduces the amount of manual prompt engineering required from the user. So another strength Another strength mentioned is the ability to follow complex prompts, understand spatial relationships, and generate text within images. So, this is useful because generating readable and correctly positioned text inside an image has traditionally been challenging for image generation systems. Next, we have stable diffusion. Stable diffusion uses an approach called a latent diffusion model. To understand this, we first need to understand the idea of latent space. Instead of processing every individual pixel directly, the model works with a compressed representation of the image called the latent space. The model starts with noise and gradually removes that noise through multiple steps until it produces an image that matches the given prompt. Working in this compressed latent representation can reduce the computational requirements compared with operating directly on the complete pixel space. So another major advantage of stable diffusion is its granular control. Because of its open source ecosystem, developers can use technologies such as ControlNet, IP adapter, and LoRa. So these tools allow developers to control things like image structure, style, composition, or specific requirements. And prompt engineering, we designing clear and structured instruction for the. For example, instead of asking explain this, we can specify the role, the task, the required format, and examples. The second practice is retrieval augmented generation, or RAG. RAG connects an AI model with external information sources such as documents or vector databases. So this allows the model to retrieve relevant information before generating an answer. So this approach can be useful when an organization wants the AI to answer questions using its own correct or specialized data. The third practice is parameter efficient fine tuning, also called PEFT. The techniques such as LoRa and CLORA allow developers to adapt models for specialized tasks without having to fully retrain the entire model. The fourth practice is safety, alignment, and guardrails. AI systems need mechanisms to reduce harmful, incorrect, or inappropriate outputs. So, techniques such as RLHF, constitutional AI, and output validation can be used as a part of a broader safety strategy. To conclude, we have explored the major concepts behind a generative AI text and image generation model. So we looked at text generation models such as GPT, Gemini, and Llama, and image generation models such as DALL-E 3 and Stable Diffusion. We also compared their architectures, deployment approaches, capabilities, and major advantages. Finally, we discussed important production practices such as prompt engineering, RAG, parameter efficient fine tuning, and AI safety. So these are the image sources.